Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
In this lecture, we are going to learn how to use regular expressions to search for a string or a word in text. First, we're going to import the regular expressions library here into Google Colab. Then we're going to create some text. We could say the quick brown fox jumped over the lazy dog. So we have a string. Then we want to use regular expressions to search for a word like quick inside of our text. Then we'll see whether we have found the text or not. So we can display found, the value of found. Let's run the code cell, and our result of found is a regular expressions.match object if there was a match. It tells us the span, so 4, 9, which means it started at index of 0, 1, 2, 3, 4, and ended at index 5, 6, 7, 8, 9. Okay, so the 9 is exclusive, and the match was quick. If you type in a different word and rerun, then you get the value none being printed because this word was not found in the text. Then we can print out the value of what was found. So we can say if there was a found object, we can print out found.group. That will print out the value quick. If we are searching for a word that doesn't exist, then nothing will be printed because found is not valid. It's not an object. But if it is an object, if it does have a value, then we can print out its group, which is its value. You can also search for multiple words like quick brown, and then you can return quick brown. You can also search for numbers. So let's say I put in 1.1.1.1.1 into the text. Well, I can search for that as well. So I can run the cell and then I can get that value returned. So that is how you can use regular expressions to search for a word or a string inside of text. Hello everyone, in this lecture we are going to learn how to use Python to find characters by type. So I'm going to create some text such as the quick brown fox jumped over the lazy dog. Then I'm going to use the regular expressions library, and I'm going to call regular expressions find all using the \w in the text. So here I'm using a find all, and I'm searching for whatever matches a \w format. So if you run this, you'll actually get all of the letters in the actual text. Now, what if we added numbers? Well, those are going to get printed out as well. So we're getting any characters. We can also try putting in a bunch of special characters and seeing if they get printed out as well. So let's try this time. And okay, so in this case, we get 1, 2, 3, 4, and we do get the underscore, but we don't get any of the other characters printed out. So those don't fall under the \w, which is going to be for alphanumeric characters, or as well the underscore. Let's try a different format for finding by type. Let's try using just the dot. So in this case, we actually will get all of our characters printed out because the dot is just going to return every single character that is inside of our string, even spaces. So notice that In our first example, we didn't actually have any white spaces, but in the second example, we do have spaces because the dot is going to give you every character. Let's try another example. This time we're going to use backslash, but using a capital W. Okay, so this time we only get the white spaces and we only get the special characters. Okay, so we don't get the underscore, we don't get the letters. So the backslash W is going to give you all the letters and underscore and numbers, but the dot will give you everything, and then the backslash capital W will give you just the white space characters and the special characters. Alright, so that is how you can search for characters by type in a string using regular expressions. In this lecture, we are going to learn how to use Python regular expressions to find all words of a specific length starting with a specific letter, like all two-letter words starting with I. First, let's create some text such as I am Ian and I like ice skating in Iceland. Then we're going to import regular expressions. We're going to use regular expressions to search through the text using some kind of pattern. Okay, so we have the text, but we need to define our pattern. This will be a string, and we're searching for all of the two-letter words starting with I, so we'll do I followed by ston. Then we can find all of the words in the text that match the pattern. So in this case, we get in, and we also get in. I am Ian and I like ice skating in Iceland. Okay, so it looks like it found the in ice skating. So if we remove skating, then yep, it is going to remove that in. So it's actually finding the in inside of ice skating and also the in that is just the regular word. So this pattern is actually going to find not a word but a string. So it could appear inside of a word. All right, so that is how we can search for a word or a string of a specific length starting with a specific letter. Let's try another example. This time, instead of ISTON, we're going to define a different pattern. So my pattern this time is going to be the upper hat sign followed by I and then in square brackets TS. So this is a different pattern, and if we run the code cell, we actually get an empty list return. So it actually didn't find any words in this case that fits this pattern. So let's find out why. Let's define a new piece of text that says is a, his, in, I'm, him, I'm a, I'm a. Okay, so we have a bunch of words starting with I. Let's rerun the code cell, and this time, look at that. The only word returned is. That's the only one that was found. What if we changed is to I'm? Okay, suddenly we don't get anything returned. Okay, so in this case, we are going to only get the I if it also ends in S. What if we put an is in the middle of the text? Well, that is also not recognized because of this hat symbol. It means the word must be the first word in the sentence. Now, what if we had an I'm in our previous text? Well, look at that. The I'm doesn't get found either because this STON means that you must have the last letter being N. So that's why the I'm doesn't get recognized. In this case, we have the hat followed by I, so the word must be the first word in the sentence. It must start with I, and it must end in S. So what if we had its being the first of our here words? Well, this actually does get found. Okay, so its gets found, but it returns it. If I type in IDTS, that no longer finds anything. So what this is telling me is I can either have T or S, as the last word here, last letter. I can have it, I can have is, but if I put in id, that's no longer going to be recognized. What about the first example? Well, in this one, let's say we change one of our ins to is. That is actually going to be found. What about T? That's also going to be found. What about O? That is also going to be found. So what this tells me is this ston, it actually allows you to find a two-letter word that starts with I and then ends in either of these letters. Now, what if we had one of them ending in ISTS? Well, in that case, we're going to find in ice skating, then we find IO, then we find is, then we find in, and then we find is. So ISTS actually does work because we're still just looking for that two-letter string. So it doesn't matter if the word is quite long, as long as it has an I and then it ends in either STON, that two-letter string that is. So the two-letter string has to begin with I and end in either STON. For the second example, the two-letter string can here start with I, or it has to start with I. It can end in either T or S. Okay, so it could be a long string, but it just has to end in T or S. But it also has to be the first word here inside of the sentence. Okay, let's say I remove that. Well, now it's going to be is. In this case, it's its. Let's say we remove this completely. In that case, we'd never find the its because it's not the first word in the sentence. So for this example, because we added this hat symbol, it means it has to be the first word in the sentence. And it has to start with I, and it has to be a two-letter word that ends in T or S. What if we added another letter here, like S afterward? Well, now we're actually searching for its. So now we can accept T or S for the second letter. We can only accept S for the third letter. We could even keep going. We could try to find a real word like EN, so a name. Okay, in this case, we'll only find the word Ian. The string, it could be a larger word if we want to. And it also has to be the first word in the sentence. So if it's later on in the sentence, then it won't be found. Okay, so that is how you can search for a string, and you can set these specifics on it. Now, you can try a different example where we have a different pattern. We could change this to be just I and then A as the second character. So in this case, we accept I as the first letter and then A as the second letter. So we could also just have written this IA. And because there's no hat symbol, it means it can be found anywhere in the text. We could also allow for more than one letter. For example, I could allow A or B, and in this case, I would be able to have IBA if I rerun my cells, and you can find IA or you can find IB. Okay, so that's because you can either have A as the second character or B as the second character, thanks to these square brackets. All right, so that is how we can set different patterns that we want to find inside of a string. In this lecture, we are going to learn how to find an expression using regular expressions, and the expression will contain numbers and symbols in a specific format. So let's jump into Colab and let's import regular expressions and define a piece of text such as I am searching for, and we can put in something like 111.111.111.111, and we can put in a string of numbers somewhere. Okay, so just some random text here. Then let's define the pattern that we want to find. I'm going to use \d dot, and then do that 3 times, and actually 4 times, because we have 4 cases of a series of 3 numbers and then a dot, 3 numbers, then a dot, 3 numbers, then a dot, and 3 numbers. So that's what we're searching for. We're searching for this string that looks like an IP address. Then we can print out regular expressions.findAll. We're searching for our pattern in our text. And look at that, we get our IP address like value returned. Okay, so this is how you can search for a specific number and then string included inside. So if we suddenly allow this new pattern, here we are allowing 1, 2, 3 values. Okay, so in this case, you can see we actually get this whole string returned this time. So now our pattern is going to include these numbers as well. We can try this as well with a smaller value and check it out. This time we're going to get these values returned, this 111.111, and then we get the second of that, but then we also get this 123.123.1 return. So why do we get that? We get that because the \D here allows for any number, and then the dot allows for any character. So I could put in here an exclamation mark, and that's also going to be valid because this dot. Okay, so this dot is actually not representing a dot, it's representing a stand-in for any symbol. So that's why we even allow just a number to be that symbol. All right, so that is how you can fill in any number. Like, this doesn't have to be a 1, it could be any number. The \D will be filled in for that. Now, what if you had a \, period? Well, in this case, that actually forces the period to actually be a period. So no other symbol is allowed in this case because you're backslashing out of the period, which means you're looking for that directly. You're not using it as some kind of symbol because typically the period will symbol that you can fill in any character, but if you put a \, then the period no longer becomes a symbol. All right, and we can try another example with another piece of text, such as some kind of number. This is a number. You could even have a word with a number in the middle. And then we can print regular expressions.findAll with a pattern and a text. So in this case, we didn't find anything with our pattern. So let's define a new pattern, such as 2 numbers with just \D. In this case, we find all series of 2 numbers, provided that they are right next to each other. Okay, so that's what we see there. If you don't use the \D, well then suddenly the first \D can be any number, but the second one, it actually gets interpreted as D, the character. So that's why we only get 4D printed out next. All right, so that is how you can find an expression containing numbers and symbols in a specific format. In this lecture, we are going to learn how to use Python regular expressions to find an expression with a specific format. We're going to be searching for numbers that could be of any length with characters in between. So let's create our text. We can have some characters and some numbers in a format and some more. Okay, if we want to have a multi-line string, then we can just use the 3 single characters to create that multi-line string in Python. Here are more. We can have a IP address format as well. And I am making more. Okay, so here is some text. Then we're going to have a pattern. So for my pattern, I'm going to use \D to represent a number, and then I can add a plus. This plus means that I am going to allow any length of numbers. So then let's call and search for regular expressions.findAll with our pattern and our text. I'm going to run the code cell and look at what we have here. We found all of the series of numbers, okay, because thanks to the plus, it means we can allow any length for this series of numbers. What if we wanted to have some search for a character in between? Well, we can have a \d plus followed by a dot, which means it will give us the whatever character is right after. So it could actually be an exclamation mark, and we're going to get the exclamation mark for that case because this dot represents any symbol. If I use a \, in front of the dot, then I'm actually specifying that I want the dot to be a dot. I want it to be not representing anything, just being itself the dot. Then we could add in another \d plus, which means we're allowing any length of numbers after the dot. So this time we get all the expressions where we have first a string of numbers, then we have a dot, then we have a series of numbers. Okay, so we get this first series, and we don't get the one connected to it because once you find a expression, that expression can no longer be used. So that's why we have to go to the next instance, which is with the ones. All right, if I added another addition of numbers, then I would be able to find that one because it's a separate expression from the one already found. And then if I wanted to allow other characters than just the dot, I can just remove the \, from this dot here. So this time, we're going to be finding our first series of numbers and then our next series. And then here we have our other one, which actually stops. So this 111 exclamation mark actually stops right after it. Then we have the next one, then we have 111. So we have something interesting here where the dot, once we allow the dot to represent anything, then it means we can find that thing and we can actually just stop there. There don't have to be numbers immediately after. Whereas when we had the dot representing itself, well, in that case, we had to have numbers be after it. So let's say I removed this from the end. That is not going to be valid. Let's see, now we have this 1, we have this 2, then we have this 3. But if I removed it one more time, then it's not going to be valid. But if I remove the \ from the dot, well, suddenly I can include just a single series of numbers and then the dot, because this dot is allowing me to represent any character, including something that's like an exclamation mark. All right, so that's why you can put the \ back in, and now it's forcing you to keep this exact format. You could also use an exclamation mark if you don't want to use a dot, but then you have to have an existing sequence or expression where there's numbers and then there is an exclamation mark and then there are more numbers. And you could have just one number as well. You don't have to have multiple numbers for this \d plus to work. So that is how you can find an expression with a specific format. In this case, searching for numbers and then a symbol and then more numbers as the string. In this lecture, we are going to learn how to use Python regular expressions to search for an expression while ignoring capitalization. So I'm going to import the regular expressions library and then build some text like the quick brown fox jumped over the lazy dog with some words capitalized on purpose. Then let's create a pattern. I want to search for my word. This could be a word like quick. Then let's print out regular expressions.findAll with the pattern and the text. And if you add a flag that is regular expressions.I, you're going to be ignoring capitalization. So you could try to search for brown with different casing, and it's going to find for you brown all caps because you're ignoring capitalization in your pattern. Okay, so that is how you can enter in some word, and because we are ignoring capitalization, we'll find all instances of the word regardless of casing. In this lecture, we are going to learn how to find words at the beginning or end of a line. So let's import regular expressions and then define some text. We're going to use the 3 single quotes, which in Python allows you to create a multi-line string. So you can say this is a multi-line string. Welcome to regex. You will learn a lot. All right, so there's our text. Then we're going to build a pattern with R, and we can use the hat symbol, the upper hand sign, in order to search for a word like this. Then we can call print on regular expressions.find all of our pattern in our text. Then we can run the code cell. Okay, and here, notice that we don't see any value returned. So let's try again, moving the text to the very front of the line. So this time we get this return because we have that being the start of a line. What if we tried welcome? Okay, in this case, we don't get welcome returned because it's not at the start of the string. What if we wanted to include inside of our text a flag, regular expressions.m or regular expressions.I? Here we have two flags. This time we actually do get welcome return because we are now using the M flag, which means that we can search through a multi-line string and find where our sentence or our line begins with that word. And it has nothing to do with the actual sentence itself. If we change this, then we'll no longer find welcome. So it has to do with the line. So if you hit enter, that's a new line every time you have a line break. Let's say you have a line break with \n. Well, in that case, it actually will find two welcomes because \n creates a new line. And even though you don't see \n in this text elsewhere, there actually is a \n hidden. Every time you hit enter, a \n is created to start the new line. Then we also have regular expressions.I. The I flag means that we are allowing any casing. Now, similarly, we can also check for the end of a line. So we can search for something like lot and then use the $sign, which means we're looking for where this word will end a line. And if we search for that, you have to make sure you include any dots that might appear as well. Okay, so in this case, we are including the period, so we're able to find a lot because it ends the line. If there was something after the lot, well, then we'd no longer have it shown because it doesn't appear at the end of the line. But if there was a line break symbol, then it actually, here, let's see, if we didn't have that space after it, then we see lot, as long as there's no space right after it, because the space is considered a character that ends the line right before the line break. So that is how you can search for a string at the beginning of a new line or at the end of a line. In this lecture, we are going to learn how to find independent words using Python regular expressions. So let's define a piece of text. You can use multiple lines with the 3 single quotes. You can say this is an example of searching for independent words. Let's find an example of 1. Okay, so here we can add some extra numbers to some of the words for some differentiation. Let's build a pattern, and we're going to use \b and look for a word. Then we can allow 0 or 1 to be after it, and then \b. So this is going to allow us to force the word to be an independent word, not just a string that could be in the middle of a bunch of other content. Okay, so we can test this out by calling print on regular expressions.find all of our pattern in the text. If you run the code cell, you get example 0 and example 1 returned. You don't get this second example 1 returned because it's not an independent string. What if there was some characters after it? Well, still, it's not an independent string, so we don't have those found. We only have found the independent strings because of this \b. If you remove one of the \b's, now we are allowing any series after that. Okay, but we're still only going to find the actual string itself. All right, so this allows you to find independent words instead of a word that could be inside of another word. So instead of finding a string, we're finding a specific word. And to do that, we use this \b followed by the word that we want to find, and you can add extra options as well, like 0 and 1. So this means that you could have 0 or 1 be after the word example. Then we're also allowing that the word must be independent. All right, so as soon as I put something else after example 1, well, it no longer becomes a valid expression that can be found with that pattern.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.